Okay, 9.2. Now, the unit circle is just a circle where the radius is 1. Okay? And then these coordinate points are just values of x, like this is the x direction and this is the y direction. Okay? And if you're referencing this angle here, this would be like the adjacent side, the opposite side, and the hypotenuse. Okay, and the radius is 1. Because the value of the radius is 1, we have these coordinate points, and we have the different values for our trig functions that go along with any particular angle. So for sine, sine opposite over hypotenuse, that would be y over 1, which is just y. So the sine value represents the y value. Cosine, then, would be adjacent over hypotenuse, that's x over 1, which is just the x value. Tangent is the side opposite over adjacent, so that's y over x. Okay, so whatever that is, y over x, whatever those values are. Now the coordinates, if you're going to write down the coordinates, if sine is y and cosine is x, you could say then we have a coordinate point of cosine sine when you find out those coordinate points, which is the x and the y. So technically also the tangent is the sine over the cosine. Other information. Okay. Now some values that we're going to pay close attention to. We're going to gather a lot of information on these values. We're going to reference these quite a bit, so we want to become familiar with these angles, their radian measure, and the coordinates that go with them. Okay, so these are some nice angles that are used frequently. These angles here at the quadrant marks, like 0 and 360 or 90, 180, and 270, they're called quadrantal angles. Okay, so if the value of the hypotenuse is 1, that's like the radius, like this would all be 1, okay, then this length from there to there would be 1. So if that's an x value as well, that would be 1, 0 as a coordinate point. This coordinate point would be 0 on x, 1 for y. 0, let's see, negative 1 for x, 0 for y, and 0 for x, negative 1 for y. Okay, so those quadrantal coordinate points have those values. Now, if you're using your calculator, you want to make sure the mode, if I turn it on, the mode button's right here. That mode button, when you go to it, and you highlight like degrees, hit enter so that your degree measure, or your calculator is working with a degree measure. If you're working with radians, then you go over to radians and hit enter, and now your calculator is working with a radian measure. Okay, so make sure you're in degree mode or radian mode before you start actually typing in the calculator. So if you're in degree mode and you type in, let's say the cosine of 360 or the cosine of 0, you're going to get 1. Or if you type in the sine of 0 or the sine of 360, you're going to get 0, and the same for all these others. Okay, so as we go through these, I'm just going to pull up an extra piece of paper to make notes on as we work through these here. So this is the 0 and 360. So if we want to write down the radian measure, we should probably already know what those are. 0 degrees, that would be 0 radians, because 0 times pi over 180 would be 0. But 360, that's all the way around. And if you remember, how many radians is it all the way around? Well, 180 is pi, so 360 would be 2 pi. Or you could actually go 360 times pi over 180, and that would give you 2 pi. All right, so at 0 and 360, our coordinate point is 1, 0. So the x value, which is cosine, is 1. The y value, which is sine, is 0. So sine is 0, cosine is 1, and tangent is y over x. So that's 0 over 1. So 0 over 1, 0 divided by 1 is 0. Okay, now for 30 degrees. 30 degrees, if we take 30, times it by pi over 180, you're going to get 30 reduce pi over 6. So this is pi over 6 radians. Okay. Now also note that if you have a 30-degree angle, your triangle is going to look something like this. You're going to have 30 degrees. Now your unit circle, the radius is 1. And if you remember, so this would be the 60-degree angle side. So if you remember our special right triangles, this is the short side, this is the long side. If you remember in 30, 60, 90 right triangles, the short side is half of the hypotenuse. So this would be 1/2. And the long side is the square root of 3 times the short side. So the square root of 3 times 1/2 would be square root of 3 over 2. Okay, so then my x value and my y value, my x would be square root of 3 over 2, and my y value would be 1/2. So the x value is cosine, so that's square root of 3 over 2, and the y value is sine 1/2. Now for tangent, that is going to be y over x. So y, which is square root of 3 over 2, over x, which is 1/2. I have that backwards, sorry. So it's y over x. Y is it's 1/2 over square root of 3 over 2. Sorry. Okay. So when you're dividing by a fraction, if you remember, we multiply by the reciprocal. So the bottom part here would be 1. So it's just 1/2 times 2 over square root of 3. So you times straight across. So it's 2 over 2 square root 3. Well, those reduce, so I end up with, drop down here, 1 over the square root of 3. And then we always simplify our fractions. If we have to rationalize the denominator, we can't have the square root in the denominator, so we multiply by the square root of 3. So on top we'll have the square root of 3, and on the bottom we'll have 3. So the tangent is the square root of 3 over 3. Okay, for 45, 45 is, let's see, 45 times pi over 180, that is pi over 4. Now you can memorize these. Once we get to 60, I'll show you a little more, but 45 degrees, pi over 4. So the denominator matches the first of the 45. So 45, pi over 4. It's just how they go together. It's how I remember them. We're going to use these a lot, so you're going to want to become very familiar with these. So a 45, 90 right triangle with a radius of 1. If you remember, the x and the y were the same in our 45, 90 right triangles. And to get there, each of these, so x is going to equal the hypotenuse divided by the square root of 2, because if we go the other direction, if we had, say, a side like x, okay, if we times it by the square root of 2, that equals the hypotenuse. Well, the hypotenuse is 1 in this case. If we divide by the square root of 2 to solve it, x is going to be 1 over the square root of 2, each of those. But 1 over the square root of 2 can't be left like that. We have to simplify or rationalize the denominator. So we multiply by the square root of 2. Square root of 2 over 2. So now that becomes my x, and since they're the same, it's the x and the y. So square root of 2 over 2 and square root of 2 over 2. Okay, so the sign, which is the y value, is the square root of 2 over 2. Can't mess this one up because those two are the same. And then tangent, if you take the square root of 2 over 2, which is the y value, over the square root of 2 over 2, which is the x value, well, you're dividing the same thing. So that's just 1. Anything divided by itself is 1. For 60, if we change 60, we're going to times by pi over 180, we get pi over 3. Now how I remember the 30, the 60, and the 45 is that the 30 and the 60 are kind of backwards from each other. Pi over 6 denominator goes with the 30. Pi over 3, the denominator, goes with 60. 3 and 6, 3 and 6 are just, you know, flip-flopped. And the 45 is the 4. So let's see. If I have a 30, 60, or if I have my 60, this will be the short side, long side. There we go. So if this is 60, and this is 30. Now this is the short side, the x, and the long side is my y. This is 1. So this would be half of that. This would be the square root of 3 over 2, just like we did with the 30, 60, 90 on the other one, only a different reference angle. My x value would be 1/2. My y value would be then the square root of 3 over 2. You notice from the 30, they're just flip-flop. Okay, the x and the y are flip-flop. So the sign then would be the y value, which is square root of 3 over 2. And cosine would be the x value, which is 1/2. And now the tangent. Tangent is going to be the, well, y over x. So square root of 3 over 2 over 1/2. So I just times by 2. That becomes 1. This becomes, that reduces, so it's just square root of 3. Okay? Now for 90. 90 is a quadrantal angle, so go to 90. We know that is pi over 2. It's half of 180, so it's half of 180. And 0, 1 is that coordinate point. It's a quadrantal angle. So the sine is the y value. The cosine is the x value. The tangent is the y over the x. Now when you divide by 0, it's undefined. You'll get an error message on your calculator. And it's not going to work. 180, that's pi. Just pi. That's pi. 360 is 2 pi. So that coordinate is -1, 0. And so the sine would be the y value. Cosine would be the x value. And the tangent is the y over the x. So 0 divided by -1 is 0. So note the difference. Dividing by 0, undefined. The 0 on top, 0. Okay? And 270, that's 90, 90, and 90. So 1/2, 3 times. 1/2, 1/2, 1/2. So 3 halves. Yeah, so 3 halves. 3 pi over 2. Or you could just take 270 times by pi over 180, and it's coordinate point 0, -1. So the y value is -1, the x value is 0, and so y over 0, oops, the 0 is undefined, dividing by 0. All right, we're going to come back to this chart quite a bit, so hopefully you've got that filled in for the next page. Let's see, okay, we got signs of trig functions. Now, the quadrants, we start here. This is quadrant 1, Roman numeral, quadrant 2, quadrant 3, quadrant 4. Okay? Now, your x and y values. So, in quadrant 1, your x value is positive and your y value is negative. Okay? In your quadrant 2, the x value is negative, the y value is positive. Quadrant 3, your x value is negative, y value is negative. And in quadrant 4, the x value is positive, and the y value is negative. I'm mistaken, quadrant 1. It's positive, positive. I don't know what I wrote down there. Positive, positive, negative, positive, negative, negative, positive, negative. Okay, so I've got them, the positives and the negatives. So the question is asking which trig functions are positive in quadrant 1. Well, if they're both positive, that means the cosine and the sine are positive. The inverse functions, secant and cosecant, are positive. And if you divide them, you have tangent and cotangent. So they're all positive. So all. Quadrant 2. Cosine is negative, sine is positive. So in quadrant 2, sine is positive and its reciprocal function, which would be cosecant. What about the tangent and cotangent? Well, you divide those to get the tangent and cotangent. So if you divide those, it'll be negative, so it's not going to be tangent, cotangent. We want the positive ones. Quadrant 3. They're both negative, so sine and cosine are out. But if I divide those, it's positive. So my tangent and cotangent would work to be positive. And in the fourth quadrant, my cosine is positive, my sine is negative. So cosine is positive, so cosine and its inverse, which would be secant. And if I divide them, I get negative, so tangent's out. Okay. So now, looking at that, example 1 says if the tangent is greater than 0, that means where the tangent is positive. So the tangent is positive. So that's got to be where, when you divide the two, x's and y's, you get positive. So that's quadrant 1. You divide those and get positive. And, quadrant 3. You divide those and get positive. So I would say quadrant 1 and quadrant 3. All right, secant, so that's just the reciprocal of cosine. And so it's not going to matter. We could just say, where is the cosine going to be negative? Because it says less than 0, so that's negative. Where's the cosine going to be negative? Because if you do the reciprocal, the positive and negative is not going to matter. It's going to stay with. So where's the cosine negative? Well, let's see. The cosine is the x value. Well, not in 1. In 2. And 3, looks like. And not 4. 2 and 3. Okay. Where's the sine positive? It's greater than 0. Where's the sine positive? Where's the sine of the angle going to be positive? Well, the sine is the y value, so it's going to be 1. And 2, the sine's positive. And looks like the other y values are negative, so just 1 and 2. And let's see, what about the cosine being negative? I want the cosine to be negative. Oh, and the cotangent. Well, it's essentially, I could say 1 over the tangent. So I could just say the tangent, because if I'm dividing, negative will travel no matter which way the fraction is. So if I want the tangent to be negative and, oh wait, tangent to be positive, or cotangent to be positive, and cosine to be negative. Okay, so I gotta find out where this matches up with for any of those. So where's the cosine negative? That would be in 2 and 3, where the y values are negative. Now, out of those two, which one has a tangent that's positive? Well, if I divide those, I need it to be positive. Oh, that can only be here in 3. Divide those two, I get positive. Okay. So, now I'm going to draw my triangle, given this information, and then find the sine. So I want, here tells me where I'm drawing the triangle. It's between 2 pi, which is 360, and 270. So it's between either quadrant 3 or 4. So it's one of these two, between 270 and 360 going this way. Between 270 and 360. Okay? Cosine is what? Let's see. X over R. Right, if you look at the last page, the page we just did, cosine is x over the radius. So the radius is 13. The x value is 12, so that means it has to be in quadrant 4 for the x value to be a positive 12. This is 13. So my x value is going to be negative because it's going down. It's in quadrant 4. Well, how do I find the x value? Well, I know that my x is 12, so 12 squared plus y squared equals r squared. Do the Pythagorean theorem. So 12 squared is 144, so y squared equals 13 squared is 169 minus 144, so y squared equals 25, so y equals 5. But over here, since it's in quadrant 4, my y value has to be negative 5. Okay, so now I've found all 3 sides, so now I can find the sine. So the sine of the angle, okay, is going to be the side opposite over hypotenuse, or the y over the r. So it's negative 5 over 13. Okay? There's stuff like this on your quiz. Let's see. Okay. Using reference angles to find trig values. All right, so this requires a little extra scratch paper here. So I'm just going to pull one up and do these one at a time here. Maybe I'll zoom in a little. Okay. So if I'm going to find the sine of 150, I'm first going to find the reference angle. So I'm going to just kind of draw where that would end up so I can figure out what my x and y values are going to be. So sine of 150, so let's go to 150. So there's 90, and well, 180 would be the all the way down, so 90 plus something is 150, plus 60 more, be 150. So what's left? 150 to 180 leaves me 30 degrees. So 30 degrees is my reference angle. So what I'm going to do is draw that triangle. So if that's a 30-degree angle, I'm going to draw that triangle. It creates a 30, 60, 90 right triangle. And we're talking unit circle here. If I'm just trying to find the exact value, okay, I want the fraction. I want the, square root of whatever over whatever. So this would be 1/2, and this would be the square root of 3 over 2. So the way I found that is because I go back to my chart, and I look at 30. 30. X is square root of 3 over 2, and y is 1/2. Okay, we just did that, right? Okay, so refer back to that chart. Now, since I'm in the second quadrant, this value, x, is negative. So that'd be negative square root of 3 over 2. This value of y is positive, so that stays 1/2. Okay, so this is why we have to draw it out to figure out what quadrant we're in, so we can know if x and y have sign changes. Okay, so the sine of 150 is the same as doing the sine of 30, but just knowing what value is positive or negative and adjusting it when we write it down. So sine of 150, the sine is which value? It's the y value. So in this case, it would be what? The 1/2? The y value? Okay, so that would be the exact value. Tangent of 300. Let's find out what quadrant we're in and find the reference angle. 300, so let's see, 90, 180, 270, and 30 more make 300. So what's left would be 60. So my triangle is going to look like 30, 60, 90. Okay, so my x value, so if I draw the triangle, my x value is positive, my y value is negative. Okay? So now you fill in the number, the x and the y with your chart. Go back to your chart, the 60-degree angle. Okay, what's the values? X is 1/2 and y is square root of 3 over 2. So x is 1/2. So this would be negative square root of 3 over 2. And we want the tangent. So what is the tangent? The tangent is the what? The y value divided by the x value. So the y value divided by the x value times by 2 times by 2. We've already done this on the chart if you look back at your other chart. But since we're in the fourth quadrant, it would be negative square root of 3. Okay, cosine, negative 135. Let's draw where we are. Negative 135, so negative 90 and what, 45 more, okay? So that leaves me 45 to there. So my x is going to be negative, and my y is also going to be negative. And so 45, 45, 90. So I'm going to go to my chart. $45. Oh, they're both square root of 2 over 2. Okay? So in this case, the x would be negative square root of 2 over 2, and the y would be negative square root of 2 over 2. Okay, so cosine is which one? It's the x. Well, they're both the same, so it doesn't matter, right? So negative square root of 2 over 2. Okay, let's go down to the next ones here. So the cotangent of 315. So let's draw 315. So 90, 180, 270, and 270, and what, 45 more, it looks like? Be 315, so what's left would be 45. So we have, here's your right triangle. X would be positive, y would be negative. Okay? So what we just did 45, just barely. They're both square root of 2 over 2. So this is square root of 2 over 2, and this would be negative square root of 2 over 2. So cotangent, which is 1 over the tangent, so we figure out the tangent and flip it. So the tangent would be, well, we're dividing them, right? Tangent would be same thing. Tangent would be the y, negative square root of 2 over 2, over the x, square root of 2 over 2, which is negative 1, right? Well, if we flip those for the cotangent, it'd be square root of 2 over 2 over negative square root of 2 over 2. Well, it's the same thing, right? When you divide them, it's still negative 1. Just because the sign is on top or on the bottom, it's not going to matter. Okay, so cotangent is still negative 1. Tangent negative 240, let's draw. Negative, so negative 90, 180, 180, and what, 60 more? Make negative 240. So this is 60. So my x would be negative, my y would be positive. So reference angle of 60. So I'll just kind of mark that. 60 degrees is what we're looking for. So 60, look at my chart. So for 60 degrees, x is 1/2 and y is square root of 3 over 2. So x is 1/2, so negative 1/2, and square root of 3 over 2. But I want the tangent, so I'm dividing them. So I'm going to go square root of 3 over 2 over negative 1/2. You can look back at your chart, it's on there. Times by 2, times by 2. I'm going to get square root of 3 over negative 1, which is negative square root of 3. Okay, let's see. Secant of 420. So secant, we're just going to flip the cosine. Now, on a side note, if you were in degree mode and you took your calculator and did tangent negative 240, you're going to get some decimal answer. And so if you do like square root of 3, it should be the same thing. Or square root of 2 divided by 2, you'll find the cosine of negative 135. Negative whatever. Decimal answer. But we're just finding these, when we say exact value, we want these fractions and such. Okay, secant of 420. So let's go to 420, so 90, 180, 270, 360, and 60 more. Make 420. So my x will be positive, my y will be positive, because I'm in the first quadrant. So 60. So I'm going to use 60. And I think we just did 60. So on 60, y, let's see, x is 1/2 and y is square root of 3 over 2. So x is 1/2 and y, x is 1/2 and y is square root of 3 over 2. So what the secant, which is the cosine flipped. So let's do the cosine. The cosine would be, cosine is the x value, right? So that's 1 over 2. So we flip it, it would be 2 over 1. Oh, okay. So the secant would be 2. All right, let's keep moving. Now we're changing gears to radians. Okay, we're changing to radians. So if you put your calculator in radian mode, and you could type in cosine and then 11 pi over 6, you'd get a decimal answer. Okay? But we're going to find the value that we've been looking for as far as our unit circle goes. So let's find out where 11 pi over 6 goes. So the key to this is figuring out where it fits in the as far as the fractions. So we're talking sixths. Everything is in sixes. So if 1 pi, that would be 6 over 6. 2 pi would be 12 over 6. So we're going to be 1/6 less than that. So 6 over 6 and 5 more. And how many were left? 1 pi over 6. So that triangle, So that triangle would look, I don't know, something like this. So this is pi over 6, which is 30 degrees, okay? And then my x value would be positive, my y value would be negative, since I'm in the fourth quadrant. So we go to our chart. We're looking at the 30 degree or the pi over 6. So 30 degree, pi over 6, those values are square root of 3 over 2 and 1/2. Square root of 3 over 2, and then since this is negative, negative 1/2. So what is cosine? The cosine is the y value, so it's negative 1/2. No, wait, sorry. Cosine is the x value. Ugh. What's going on today? Back it up, back it up. Cosine is the x value, yeah. Square root of 3 over 2. That didn't sound right. Good. Glad I caught myself. Thanks for the shout out, anyone? All right, let's see, cosecant. So let's draw. Where is pi over 4? Let's see, well, if you want to look up the degree measure back on your chart, you could say, oh, that's 45 degrees, so you could maybe have a better idea of drawing that. So there's your triangle. X will be positive and y will be positive. 45 degrees or pi over 4. Cosecant, we're just going to flip the sign. So we're going to find sine and flip it. Okay, so here's the 45. Let's see, square root of 2 over 2 for both of those. Okay, so what is the sine? The sine is the y value. So the y value is square root of 2 over 2. So I have to flip it for the cosecant. So I have to flip it 2 over the square root of 2 for cosecant, which then means I have to simplify it. So I'm going to go 2 over the square root of 2 times it by the square root of 2 to simplify. I get 2 square roots of 2 over 2, which is then just the square root of 2. Okay. 4 pi over 3. Well, let's find out what quadrant we're going to be in. 3 over 3 would be the 180. So it's 3 and then 1 more third. So this would be 1 more third, so pi over 3. So there's my triangle. So pi over 3 would be 60 degrees if you want to do that. My x will be negative, and my y will be negative. So let's go to 60 degrees, or pi over 3, on the chart. 60 degrees, pi over 3. That's 1/2 for x, and square root of 3 over 2 for y. 1/2, so negative 1/2, and negative square root of 3 over 2. So what is sine? Sine would be then the y value, so negative square root of 3 over 2. Getting the hang of it? Now let's see. All right, let's see, negative 5 pi over 4. So let's draw that. So negatively, so there's 4 over 4, and then I need 1 more fourth. Now, if you're uncomfortable drawing when the fractions and the radians, you can always change that to a degree measure and then draw it to see what quadrant you'll be in. So 4 over 4, and then 1 more pi over 4, so that's 45. So let's make a triangle. This will be negative for x and positive for y. Now, if you remember, if you haven't memorized, 45 degrees, they're both square root of 2 over 2. So look back at your chart. So this will be a negative square root of 2 over 2, and this will be a positive square root of 2 over 2. So we need to find the quadrant so we know how to deal with our x's and y's, making them positive and negative. All right, so we want tangent, we're just putting one over the other, right? Y over the x, so the y over the x, those are the same thing, but if we're going to divide them, it's going to be negative, so we'll just do negative 1, since we divided the same thing. 19 pi over 6. Let's see what quadrant we're going to be in. 6 over 6, 12 over 6, 18 over 6, and one more 6 will be 19. So that is just pi over 6. So it's just going to be sine of pi over 6 with adjusted x and y values. So negative for x and negative for y. We're in the third quadrant. So what is pi over 6, or 60 degrees? Or, sorry, 30 degrees. Pi over 6. 30 degrees, pi over 6. So square root of 3 over 2, 1/2. Square root of 3 over 2, so negative square root of 3 over 2, and negative 1/2. And we want sine, so sine is the y value, so negative 1/2. All right, last one. The secant, so we're just going to flip the cosine. So we'll just make a note, we're going to flip the cosine. We want pi over 2. Oh, pi over 2, that's just 90, right? Okay, so 90, the two values there are x is 0 and y is 1. 0, 1. And you can look back at your chart as well. So the cosine is what, the x value? Cosine sine? So if the cosine is 0, what's 1 over 0? Oh, any of that on the paper? Okay, let me back it up. I don't think I saw that. I drew it, okay? 90 degrees, which is pi over 2. Look back at your chart. The coordinate is 0, 1. And cosine is 0. So for secant of pi over 2, that would equal 1 over 0, which is undefined. So 1 over 0, undefined. All right. Go get them. Let me know if you have any questions.